All right, hey everyone, welcome. Thanks for coming to our session. My name's John Earl, and I'm an engineer on the Design Systems tooling team. And I'm joined here by Billy Ma and Matt Holland, who are both engineers on the Sales Cloud team. And today we're going to be talking to you about design system adoption with developer tooling. So before we begin, I just want to let you know that we are a publicly traded company, and you should make all your purchasing decisions based on what's available today. So I want to begin by talking about what is in a design system. So at a higher level, a design system is a collection of repeatable design patterns and reusable code that we refer to as components. But I want to emphasize that it's not just the code and the actual framework itself that's the most important part of the system. Equally important is the component documentation, the pattern guidelines, the iconography, the accessibility guidelines. All of these elements come together to form a very complete system. So the Salesforce Lightning Design System, or SLDS, is a collection of all of these elements designed to help you build and design efficiently on top of the Salesforce platform. So why would you want to use a design system? Well, a good design system is scalable. So as your design system matures, you're spending less time and energy rebuilding these foundational components because the infrastructure is already there. A good design system is efficient. So because you have these components, designers and developers are able to spend more of their time focusing on the actual meaning and purpose of the product that they're building or designing, instead of constantly reinventing the wheel. A good design system is visually cohesive. So its patterns are anchored in purpose. Its reusable components reinforce its visual style, as well as the branding. And overall, this just creates a more user-friendly, cohesive user experience. And this is important because inconsistency in an experience is taxing on end users. And finally, a good design system is shared. So these levels of abstraction, the different elements of the system, the components, resemble a shared language that's known across PMs, developers, designers, interdisciplinary in the company. And it allows everyone to jump in and collaborate on projects much more easily. So design systems are great. But there are actually a lot of challenges to adoption and correct usage of design systems. And we're going to jump into those first. So I think one of the most important and probably difficult challenges to adopting and using a design system correctly is needing to learn and apply the rules of the system. So HTML and CSS are notoriously flexible. They're flexible to a fault, in fact. There's no compilation errors. There's no strict typing. They're designed to work even if your code isn't written correctly. So it's really easy to head down a bad path. So one role of a design system is to sort of rein in this flexibility and make it easy to do the right thing and hard to do the wrong thing. And that's sort of the mantra we like to say on the SLDS team. To accomplish this, design systems introduce rules for operating within the system. These rules can include what particular design token you want to use in a circumstance. So you need a 2rem token. And there are many 2rem tokens. But there's only one particular token that works for that circumstance within that component. These rules can also include what level of the DOM particular classes can be applied to, what parent classes need to be in place, and what particular HTML element that class needs to be applied to. And then finally, the rules can also cover what utility classes you have available and the proper usage of these utility classes. So as you can see, when working with a design system, this can become pretty overwhelming. It's a lot of rules to know. It's a lot of rules to apply. And it makes it difficult to adopt and use design systems correctly. In addition to this, when you're adopting a design system, you might need to alter your workflow to operate within the system. So you might need to learn the levels of abstraction of the system, learn the component names, possibly interface with your designers differently, alter your CSS authoring style to match the system. So that's just yet another challenge of adoption and more overhead for the system.
Another challenge is keeping up with design system changes or naming conventions. An example of this is the BEM naming update that SLDS did pretty recently because of some customer XML parsing issues. Having these types of changes can cause disruptions down the line if the engineers are not made aware of these changes. Another challenge is human error. Humans are humans, and we all make mistakes that can easily be made with little to no side effects in the code. Engineers not familiar with design systems or UI code are very often the ones that we use the design system incorrectly. Adding work items to correct these mistakes would be a costly, entirely manual process. These are some real-world examples that we found in the code line. They don't work, but they didn't break anything. I think my favorite is opacity level number 2.
We can't eliminate all of these challenges. We can go a long way to mitigate them. And at Salesforce, we like to do this through developer tooling. And we think the most important part of this is really meeting the developers where they are, so tapping into their workflow directly. So let's talk about how we can start introducing this developer tooling. So you'll remember earlier I mentioned that CSS and HTML are extremely flexible, flexible to a fault. It's sort of the Wild West. So one role of a design system is to rein in this flexibility. And the way it does this is through rules. So design systems have to have rules. They're an integral part of the system. But it's really important to note where you define these rules. So these rules should really be defined in metadata, thus becoming an intrinsic part of the system, instead of just prose or living alongside the system as documentation. So again, these rules can cover composability restrictions, proper token usage, proper class usage, everything I went over before. So let's see what this particular metadata looks like in SLDS. So you'll see two types of our metadata on the screen here. On the right-hand side is the restriction rules, or what we like to call the restriction rules. And these are rules that sort of mimic the DOM structure of a component. So it tells you where you can apply classes to and what parent classes need to be in place. So you can see here we have an SLDS carousel selector. And we have a restrict attribute right before that, or right below that, sorry. So that class can be applied to a div, and only a div. If we crawl down that tree, you can see below that we have an SLDS carousel stage class. So that class can be applied to a div within the scope of the SLDS carousel class, as you see there, and so on. So together, those sort of form the composability rules of the system. Now on the left, we have the token rules. So this is one particular entry from our token rule set. You can see it describes background color on a highlighted search. So we have several attributes that help you to use that token correctly. You can see a scope attribute. So is this a global token? Is this a component-specific token? You can see the category of that particular token. Super importantly is the comment section. This describes to the end user how and when they should use that particular token. You got the type and the CSS properties and the value that it resolves to. So for utility classes, we have very similar metadata in that it'll describe a comment. So it'll tell you how to use those particular utility classes, as well as the CSS properties that it pertains to. So it's great. We have all this metadata. It's encoded. It lives with the system. That's awesome. But how do we actually surface it to the developers? How do we get them to actually start using these rules when they're developing? And at SLDS, we've taken an API-driven approach. So we're starting to develop this API around our design system and expose these rules that, again, live with the code, so that others can take advantage of these rules and use it directly in their workflow. So you might be wondering why we didn't just build an enforcer. Why are we delegating this enforcement to other teams instead of just building something within our team and requiring other teams to use it? Well, at Salesforce, you're actually not required to use SLDS. In addition to that, we actually did build a plugin a long time ago. We built a Selenium plugin that did all the enforcement for us, and we shipped it out to other teams. And what we noticed is that no one used it. And this is because that one plugin didn't fit into every particular developer workflow. So different teams use design systems differently. And they want to enforce rules in different ways and at different points in that development lifecycle. And different teams use different technology stacks. So we can't force it. We couldn't build an enforcer and require people to use it. It just wasn't flexible enough for all use cases. So instead, we developed this approach where we're meeting developers where they are, tapping into their workflow.
So what's next? All of this API design and tooling is fantastic, but how do we get in front of the developers? How do we put this metadata and these restrictions into the engineer workflow? There's a need for a core recommendation engine that works with the design system to help guide engineers through how to use the design system. How are we going to achieve this? Well, we built an SLDS Validator tool. The SLDS Validator tool works like this. It pulls down the latest design system metadata from the API. It ingests UI files and uses the metadata to validate those UI files to provide a list of recommendations that the engineer can use in their current workflow. what type of recommendations are there? Anything from design tokens in place of static variables in your CSS, utility classes in your markup instead of design tokens or static variables in your CSS, errors to catch incorrect or deprecated tokens or utility classes across your markup and CSS, and there are even errors to flag base component overrides in your CSS. So if you're overriding an already existing SLDS component with an already existing property value, it'll let you know. The validator tool can be run as a standalone tool over specific files, and it's actually being currently run in Sales Cloud CI for the last 3 releases. So using this validator tool and the recommendations, we were able to build IDE extensions that can provide real-time feedback to the engineers. Using these recommendations, we can provide the following quick fixes: token utility class recommendations, syntax highlighting to let you know which quick fixes are available and how you can actually use these recommendations in the code, autocomplete so you can find utility classes and design tokens quickly, and context awareness so the tool will actually know if you're coding in Aura or LWC and provide the actual metadata associated with that in autocomplete. So let's do a little coding exercise. Here are 5 things that are very common for an engineer to go through on a regular component, nothing special, to get a little bit closer to full SLDS compliance. We're going to remove some static values. We're going to remove anything invalid. We're going to add some special utility classes to the component markup. And we're going to check some JS to see if there's any invalid classes. So here we go. So I'm in the CSS, and the first thing I'm going to do is move the margin and padding into utility classes. I'll go to the SLDS website and cross-reference the property values with utility classes that are in Lightning Design System. So it's pretty easy to navigate, but jumping back and forth between code and a website can be a little daunting sometimes. And in the middle, you might be able to catch some bugs. So pretty straightforward, adding all of this. I'm sure if there's any developers out here, this is not uncommon for you jumping back and forth. You have dual monitors, it's probably a little bit easier. So now sometimes updating padding, making sure it's the correct rem. So I think you guys get the idea. So here, we're going to propose a new workflow. Here's what it looks like using the SLDS Validator extension in VSCode. The first thing you'll notice is the syntax highlighting, showing you what's incorrect and what you can update things to. Right there, it updated a CSS property and added the corresponding utility class in the component. So we already lapped the previous workflow in under half the time. So now we're updating design tokens. We're going to update this design token to a utility class on the actual markup. So as you can see, it's much faster, it's much cleaner, it's much more intuitive. I didn't even walk through how we would try to find invalid tokens in your CSS or in your markup without a tool like this. It would be a manual process where you'd have to cross-check a number of things. Here it's highlighting the autocomplete with the number of SLDS classes. And this is showing that it actually even works in JS when adding invalid classes. So there you go. That's how you can use this tool in the real world in the engineer workflow.
So as Matt mentioned, we actually been running this in the Sales Cloud CI for a year. So we've been tracking usage of the component, like the recommendations, against our component files. Salesforce internally right now is around 24,000 Lightning components. We basically took all the Sales Cloud file, which is around 21% of them, and we monitored them for the last 3 releases. And if you see on the left side, the bar graph right there, the darker blue lines actually show globally that our CSS recommendation has been increasing, which makes sense. We are creating new features over time. But if you look at the lighter blue line, that represents Sales Cloud one. We actually are doing a negative recommendations, almost to a 10% decrease every single release. So this is how successful the tool has been for us. Give it back to John to talk about how we actually dogfood it in other scenarios.
Sorry for that. So in addition to actually helping Sales Cloud itself, by surfacing this information and Sales Cloud building this VS Code extension, it's actually helped SLDS as well. So we're sort of eating our own dog food in a sense. And this is because we're able to sort of crowdsource bug identification, right? So if we're releasing this metadata out there and teams are starting to use it, they're able to come back to us with bugs that they find. So it's not only helpful for the consuming developers, it's also helpful for SLDS itself. I know Matt and Billy have both come back to our team with particular recommendations or things that they've found and sort of bugs in our system, including improper restriction rules, missing scope attributes, so sort of just a few little things here and there that our test suite couldn't possibly cover and the size of our team really couldn't catch. So it's been fantastic for us. So with that, we'd love you to check out some resources to learn more both about SLDS as well as what Sales Cloud is doing and their VS Code extension. So I want to encourage you all to visit the SLDS booths. There's a booth in Camp Design, which is upstairs on the second floor, Camp and Platform Point over there. We'd love you to complete the brand new Trailhead module that we created. We'd love you to visit our website, getsLDS.com. And then finally, stay tuned for this awesome extension that Matt and Billy's team have worked on. It's going to be available to all of you to use in your Salesforce development very soon, and open source shortly after that. So I think we have about 3 minutes for questions if anyone has anything. But thank you all for joining us. The question was, why are developers at Salesforce not required to use the design system, or designers as well? It's part of the culture. We don't want to force you to use it. We want you to want to use it, right? And I think that's what we're trying to do through this tooling. I think we don't want to pigeonhole designers into using one specific tool. So I think it does bring up a better culture if we're just trying to make it more of an asset rather than something you're forced to use every day. That's kind of how we went about it. All right, well, if there's no other questions, thanks again, and enjoy your time at TDX.